In the previous lesson, we learned how to balance redox reaction, and the first one is we balance a neutral redox reaction. And for that, we just have to use Leo the line says GER by looking at in terms of reduction and oxidation as a half cells and combine them together. That's all we have to do. But then we have redox reaction that happen in an acidic or basic condition, and that change all the steps, because we don't balance the electron until step 5. And we also look at the specific steps in terms of balancing an acidic redox reaction, right? Now let's look at the basic redox reaction. The beautiful thing between the two is that they are the same, except that in a basic condition, we just need to add in one extra steps. And I put a 3-star there for a reason, because it can happen in step 4 when we balance the half reaction. But here's the easy part. If we take these steps and make it the last steps, okay, rather than look at when it's in half reaction, we look at the last steps. We now are able to make a changes from a balanced acidic redox reaction to a balanced basic redox reaction easily, without going back to step 1 and look at a half reaction. So always save this for last, okay? So keep that in mind. Now let's go back and do an example problem together. Before we do an example problem together, let's look at what is that step specifically. That is, for every H+, we're gonna add OH- to neutralize. What does that mean? If the OH- and the H+ are on the same side, that will become water. Just be careful when you add OH, you're adding both sides. That way it's balanced on both sides, okay? So let's do an example problem together. In this case, I have this problem, and the oxidation number is already assigned. Now, notice how we don't look at the number of electrons until step 5, right? So why worry about the oxidation number? Because we don't care about Leo the line says GER. I show you in that step just to review, but if we look at this, we realize it actually comes in pairs in terms of half reaction. In most cases, okay, not all cases, but if you happen to forget to assign oxidation number, just look at in terms of half. Notice how we have Mn and Mn, we have bromine or Br and Br, let's go with that. So we can actually split into half. Let's do Br first. So we have Br minus, and that's going to go to BrO3 minus, okay? So what do we have? We have 3 oxygen here. Well, Br and Br is balanced. We have 3 oxygen there. So of course we need to add water molecules to balance out with the oxygen. So for every oxygen we add water. So in this case 3, so we had to add 3 water molecules there. And notice how by doing that we add 6 hydrogen, so we had to make, in this case, for hydrogen, we add H+. Of course, we have 6+ there. Okay, and that's it. Now let's go to balance the charge to look at the number of electrons. Here we have 0 here, we have 1-, so it has a net charge of 1-, or there you go. And in this side, we have 1-, then we have 1 or 1+, and then we have 6 of it, so that must be 6+. But total together we have 5+ on this side. And the question is that we need to make this size, and we need to balance the charges. What does that mean? We need to balance in this case that this side have -1, so this one must also have -1. So you can ask yourself, +5 plus what number will give us a 1-, and of course it's gonna be a -6. That means we need 6 electrons. So be careful with your basic algebra, okay? And that's it. That's all we have to do. Now let's go to the other half where we have MnO4 minus, and that's going to MnO2. Here we have 2 oxygen. Here we have 4 oxygen, and the Mn is already balanced. So over here, of course, we need to add 2 water molecules to balance out the oxygen. Then, because we're adding 2 water molecules, that will change the number of hydrogen as well. So we have 4 now. So we need to add 4H+ based on this step 4 right there, okay? Now, let's go down and balance our charges. Here we have 0 in this one and 0 in that one, so the total is 0. Here we have a 1 minus, here we have plus, and there are 4 bits, so we have 4 plus. So combined together we have 3 plus total. So we need a 3 negative electron on that side. So that this side equals 0 as well, and that side is equal to 0 as well. And that's all we have to do. Now let's combine the half cell together. Notice how we have 6 here, we have 3 there, so we have to multiply this whole entire thing by 2. So we have 6 electron plus 8 H plus 2 MnO4 minus equal to 2 MnO2 plus 4 H2O. Now the electrons cancel each other, okay? And if you happen to find electron on the same side, just flip one of them and that's it, okay? So in this case, they're on opposite side, they cancel each other out. Now the rest is combine them together, starting from the top. We have 3H2O plus Br minus, going to the bottom. We have AH plus, we have 2MnO4 minus, okay? We're done with this side. Now let's go back to the other side, where we have BrO3 minus plus 6H plus, and electrons cancel out already, plus 2MnO2 plus 4H2O. And then we just have to cancel like terms. In this case, what do we have? Oh, we have water here, so that one's 4, that one's 3, so this means we have 1 left over here. Then we have H plus, this one have 8, this one have 6, so that means this one we have 2 left over. And there you go. So this is the balanced redox reaction for acidic condition. I'm going to use a different color to change this into a basic condition. And all we have to do is for every H plus, we add OH minus to both sides. And if the OH and the H plus are on the same side, they will neutralize, they become water. That's it. Here I have 2 H plus, so I'm going to add 2 OH minus. And when we do that, we're going to add on this side as well 2 OH minus. And all we have to do is combine this together and make that water. So we have 2 H2O, and that's it. Now cancel like terms. In this case, we have 2 water molecules and 1 water. That's going to cancel out, give us 1 water molecule left. And that's all we have to do. And that is our final answer. Do you want me to rewrite this over for you again? Okay, fine, I'll do that for you. So I just want you to see the final answer. So again, I take this acidic and rewrite them here. And here is our basic condition. So this is your acidic condition right there, which I should write it first. But I forgot. Now let's go back. And that is your final answer in terms of the basic condition for this redox reaction. Just be careful, this is BrO3 minus, okay? So I mentioned to you before, right, that when it comes to basic and acidic condition, we don't worry about oxidation and reduction that much because we don't care about the number of electrons being transferred in that specific half reaction. Let's look at this problem where that really becomes important. That's because assigning oxidation number is such a mess when it comes to this type of molecules. But you can see that overall it has 2 sets. This kind of a like term, so this kind of a set together, right? So let's use that as our pattern so we can solve for the half reaction. So what I have here, this is going to be my first set. AlH4 aluminum hydride all the way to aluminum. So aluminum is balanced, then we have H plus. We don't even have oxygen. So we can just skip that. Now let's go to hydrogen. So we have 4 on that side, so we need to add 4 H plus on this side as well. Isn't that easy? Now all we have to do is balance out the charges. In this case we have 1 minus, here we have 3 plus, and here we have 4 plus. That gives us a total of plus 7 or 7 plus, okay? So that's our charge. But we need to make this side total equal to 1 minus. So 7 plus 1 number will give us 1 minus or minus 1. And that answer of course is gonna be 8. So we have 8 electrons. And that's all we have to do. Now let's go to the other half. we have H2CO, and that's going to go to CH3OH. There you go. And what we have here is, so for this half, we have the carbon and the carbon balance. Then we have the oxygen. Over here we have oxygen. Okay, balance. Then right here we have 2 hydrogen. And how many hydrogen do we have here? We have 3 plus 1, that gives us 4. So we need to add 2 more over here. Okay, and then what do we have next? We have this side equal to the net charge equals 0. This one equal to 0. And this one has 2 plus. And the total or the net charge is 2 plus. So how can I make this side to be 0? Of course, by adding 2 electrons. And that's all we have to do. Well, here we have 8. Here we have 2, so of course we have to multiply this by 4. So what we have here is 8 electron plus 8 H plus 4 H2CO equal to 4 HCH3OH. There you go. And then the electrons are balanced. Now we cancel that out. And we combine them together, starting from the top. And that's it. Let's go down to the bottom. And let's go to the other side. We're done with the reaction, starting from the top again. 4H plus. And then we go to the bottom, which is 4CH3O. Now we just need to cancel out like terms. And the only thing I see is H plus. So in this case, our answer is 4H plus. Right there. And this would be the acidic condition. Okay, so this would be the balanced redox for acidic condition. Now, I'm going to use a different color to make this into a basic condition, basically by adding OH to neutralize the H plus. So here I have 4, so that means I need to add 4 OH on this side, and I'm also adding 4 OH minus on that side, so OH minus, okay? And this becomes water, so we have 4 H2O, okay? And that's pretty much it, all we have to do. Because we don't have water molecule to cancel this side. So this is our final answer. Let me write it down for you. So this is our balanced redox reaction for basic condition. And for the one in pencils up here is for your basics redox reaction for acidic condition. Go to StreamlineED.com to download ready-to-use online practice with immediate feedback. You don't have to make copies. All of your student work is auto-graded. This will save you a lot of paper and hours of grading. The links are in the description below. Thank you.